Alright, so is 2 comma 4 a solution to this system? Well, what we do is we use the graph. Is the place where the lines intersect 2 comma 4? Well, let's see, we go over to 2 and we go up 4 and we see, lo and behold, yes it is. So yes, it's a solution to the system. Another option is you can replace the x with the 2 and the y with the 4 and see if it equals 6 in this equation and if it equals 8 in that equation. If it does, the answer is yes. But it's easy to just use your eyes and say, yes, they intersect at 2 comma 4. That's why graphs are good. So now we get to graph and see where these lines would intersect. So we have x plus y equals 5 and x minus y equals 3. So you know what we do to graph. We pick our table of values, and of course I'm plugging in -1, 0, and 1 for this first equation. And one thing that I would like to do to this equation is simply move the x over here with the 5, making it 5 minus x. And that way I can plug in my -1 and get a 6, plug in my 0, get a 5, plug in my 1 and get a 4, and I can do my ordered pairs pretty quick. If I didn't do that, I'd have like an extra step. I would plug in the -1, then I'd have to add it over to get the 6, plug in the 0 and get the 5, plug in the 1, subtract it over and get a 4. So to each his own. If you don't want to go through all that and you'd rather just plug it in and solve, you do you. I go to -1 and I go up to 6. I go to 0, go to 5, I go to 1 and go to 4. And as I keep on going, you'll notice it just keeps on going down by one value, so I can kind of make my line really perfect when I draw it. Next, let's do the next equation. This one, we have to do x minus y. So I would just sort of switch the places of the x and the y, so it would be x minus 3 is equal to y. But again, whatever you want to do. So I'm going to plug in -1, 0, and 1 into x minus 3 so that I can make my life and yours a whole lot easier. Plug it into x minus 3. Now, if you just plugged it into x minus y, you'd have to plug in the -1, add it over, get a 4, and then take the opposite of it and get a -4. But if I just put it right there, -1 minus 3 is -4. 0 minus 3 is -3. And 1 minus 3 is -2. So -1, -4, 0, -3, 1, -2, so on and so forth until we intersect over here at 4 comma 1. Take your time and just graph the line. And where they intersect is the solution, 4 comma 1. You can always plug in your solution back into each one of them to make sure it works. 4 plus 1 is 5, 4 minus 1 is 3. It works. Here's another system we can solve by graphing it the same way. Again, I like to do a little front loading and I like to solve for y first. And on this one, I'm just going to show you how you could use the slope and the y-intercept to graph, because it's another very easy way that you could graph. So I'm going to solve this equation for y by simply switching the places of these two numbers. So that gives me 3x plus 3 is equal to y. Because when you move the 3 over, you add it. When you move the y over, you add it. That's why it's positive. In this case, my slope is 3 over 1, the number that's written beside the x. And my y-intercept is 0 comma 3, this number right here. It's hard to tell what they are since they're both the same number. So you start off graphing your y-intercept, which is 0 comma 3, and then I'm going to go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And you just connect the dots best you can. Now again, if you would prefer to do the table of values, plug in -1, 0, and 1. Plug it in right here. -1 times 3 is -3, plus 3 is 0. Plugging in a 0, you get a 3. Plugging in a 1, you get a 6. So 1 comma 6, 0 comma 3, -1 comma 0. and they all kind of fall on those points. Alright, so let's do the next one. You just switch these up and you get, and we'll just do a table of values. I'll plug in -1, 0, and 1, and if I switch things up, I end up with y equals 3x minus 9. If I plug in a -1, I'm going to get a -12. If I plug in a 0, I get a -9. If I plug in a 1, I'm going to get a -6. So -1, -12, 0, -9, and 1, -6. I need to make an adjustment for this problem because this is not quite correct. I was wondering why my line was looking parallel because it's not parallel. Alright, when I move these things around, this should not be 3x minus 9. I actually need to move my 3x over here with the 9. I apologize. So it would be -3x plus 9. Now we're cooking with grease. If I plug in a -1, I'm going to get a +12. So -1, +12. And then when I plug in a 0, I'm going to get a 9. That's good. And when I plug in a 1, I'm going to get a 6. So there we go. Ooh, don't let me draw a line for you. And where they intersect is 1, 6, because that's the point that they have in common. Just happens to be one that we plugged in. Apologize for that error. On to the next. Let's solve this system. Hopefully I won't make a mistake with this one. I'm going to plot points with this one, and I'm going to use slope and y-intercept on the second one to show you versatility. So we're going to plug in -1, 0, and 1. And when I plug in a -1, I'm just going to switch these two places, so I get x plus 10 is equal to y. So I'm going to plug it into x plus 10. -1 plus 10 is 9, 0 plus 10 is 10, 1 plus 10 is 11. That's easy peasy. So I go from -1 up to 9, from 0 to 10, and from 1 to 11. So the line's kind of right there. Now if I use slope and y-intercept, that means I go to 12, and then I go up 2 and over 1, down 2 and over 1, down 2 and over 1. So it's kind of like they intersect maybe right there at 2, 8. -2, 8 rather. So let's see if I get anything. If I do -2 minus 8, I get -10. And if I do -2 times 2, I get -4 plus 12 is 8. So this is exactly where they intersect. Alright, let's try another. We're now going to graph inequalities. In order to graph inequalities, we have to have a real clear understanding about boundary lines. See, we've been graphing lines, but inequalities have an infinite number of solutions on one side of the line. So we need to appropriately draw our boundary line. And this is the difference between boundary lines. If our inequality symbol happens to be greater than or less than, we're going to create a dashed line or dotted line. And if our inequality symbol is greater than or equal to or less than or equal to, it's just going to be a regular old line, because that means that the boundary line is actually a part of the solution. The solution is less than or equal to the line. Whereas with here, the line is not a part of the solution. It's just less than or greater than the line. So here, the boundary line is going to be dashed. But when it's time for us to solve it, we do the same thing that we've always done. So let me erase this and show you what that is. So let's plug in some points, or use the slope and y-intercept, or maybe do both. We'll do both. We'll plug in -1, 0, and 1. So those are my favorites. And we plug them into the equation, 2x minus 3. So 2 times -1 is -2, minus 3 is -5. 0 times 2 is 0, minus 3 is -3. 1 times 2 is 2, minus 3 is -1. And again, you can work each one of those out right on your paper. I just want to do it mentally. Okay, so now we'll just plot them. So -1, -5, 0, -3, 1, -1. If we use the slope and y-intercept, the y-intercept is -3, and the slope is 2 over 1. So that means we go up 1, up 2 over 1, up 2 over 1, up 2 over 1, count up to 1, 2, over 1. And this little dashed or dotted line I made is my boundary line. Now, since it says y is greater than, usually when it says greater, greater represents the area that is above the graph, and less than represents the area that is below the graph. So if it's greater than, you shade above. If it's less than, you shade below. But sometimes this doesn't work, especially if it's not in this form. So the easiest thing to do would be to pick a test point. My test point is 0, 0. And we plug it in for x and y. So 0 is greater than 2 times 0 minus 3. Is 0 greater than 0 minus 3? Is 0 greater than negative 3? And it is. So since it's true, or it is greater than that, what we're going to do is simply shade the side where the point is. If it ended up being a false statement, we would shade the other side. So we only have to pick one test point. We don't have to pick like all of them. And this area I'm shading yellow is the solution to this graph. We'll do a few more of those in a moment, so don't be scared. It's okay. And good luck.